Hey everybody, my name is Morgan Rehnberg, and I'm an astronomer here at the Fort Worth Museum of Science and History. And like a lot of you, I'm currently stuck at home. And it can feel kind of cramped to be here all day and all night, but I've got a tip for you that's going to make things a lot better, and that's to go outside, even just for a minute, and look up. Because there's a whole lot of space out there in the universe, and it can be really cool to look at, even from your house. If you've got a front yard, or a backyard, or a patio, or a porch, or even a balcony like I do, you can look up and you can see the night sky. Now, I live right outside downtown Fort Worth, and so there is a lot of light pollution where I am. So I'm not seeing the Milky Way or even that many stars, but I can see the very coolest thing in the night sky, and that's the moon. The great thing about the moon is it's so big and so bright that you can see it basically wherever you are. And every time I go back and look at the moon again, I see something new that just amazes me. So I want to tell you a little bit about how you can go look at the moon, what you want to look for, and when the right time is to go take a peek. And to do my moon watching, I use a tool that I think a lot of you probably have at home right now. And it's not a telescope. It's a pair of these, binoculars. And they don't have to be fancy. I think I bought these for $20 or $30 at Target. They're the kind that you might use if you're bird watching or hunting or at a football game. But the key is that they're better than your eye. So if you look at my eye, you'll see the black part, right? The pupil. It's pretty small. And that's the only part of my eye that light from the moon can go into so that my eye can see it. And so it doesn't collect a lot of light, and it means I can't see a lot of detail. These binoculars, and these are pretty small binoculars, they're a lot bigger than my eye is. So they collect a lot more light, and that light allows me to see the moon in ways that you wouldn't even believe. And so rummage through your drawers, look in a cupboard. I bet you've got a pair of even cheap binoculars laying around, and they are the single best tool that you can use to look at the moon. Way better than using a telescope, because they're just easier to set up. They'll let you look around. They're exactly what you want, and we all have them. So go find your binoculars and let's take a look at the moon and see what we're actually going to be looking for. So here we've got a great picture of the moon that was taken by NASA. And this is showing the part of the moon we can see, called the near side. The moon always shows basically the same side towards us because it takes about the same time for the moon to make one rotation as it does to make one orbit around the Earth. And so there's not really a light side and a dark side to the moon, but there is a near side and a far side. And the near side here is something we've all seen every time we look up in the night sky. And the thing that might stick out to you first are these big dark spots. These are called maria. That's Latin for the word sea, like an ocean. And they thought that these were lakes and oceans on the moon. But today we know they're actually giant lava flows that are spreading out from ancient volcanoes that erupted millions or even billions of years ago on the lunar surface. Now, of course, we can also see some craters. So you got a crater over here, for example, and the moon doesn't have an atmosphere. And so that means there's nothing to stop incoming asteroids and comets from smacking right into the surface full force. And so the lunar surface is way more cratered than we have here on Earth. And there's also no wind or rain to erode away those craters. You might notice also that some craters have these white lines coming out of them, and those are called rays. And rays are actually really important. They're material that is thrown out of the crater when the asteroid hits the moon's surface, and they can travel for hundreds or even thousands of miles. And the rays help us date how old these craters are, because over time, as little bits of dust fall from space onto the moon, they cover up these rays. And so if you see a crater that has a lot of rays, like for example this one we can see near the south pole of the moon, we know that it was relatively recent compared to other craters on the moon. We can also find places where multiple sets of rays overlap. And if we can tell which ray is on top of another one, we can tell which of those two craters must have formed first. Now, what I just showed you is what we usually see when we look at a picture of the moon. And that's the full moon. We see the whole disk of the moon. But actually, that's not the best way to go look at the moon for yourself, because it's so big and so bright that it's just going to kind of overwhelm you, and the details won't stand out nearly as well as if you look at it when it's a partial moon, like a quarter moon or a 3/4 moon. And the part you really want to focus on is what's called the terminator. So here's a great photo of a partial moon, and it shows just how much more detail you can see along the terminator than you can in the rest of the disk of the moon. So that if you look right where the line between the darkness and the light is, you see all of those craters. And it's not that there are just craters there are actually craters all over the moon, but the light from the sun is hitting those kind of edge on. So it shows the sharp up and down nature of the terrain a lot better than if the light is hitting from the top like it is on the rest of the moon. And so this is really the most beautiful part of the moon to look at. And it's also incredibly useful scientifically. More than 400 years ago, Galileo looked at the moon and sketched the terminator, like you can see here, and he used that to calculate the height of the mountains on the moon, because he realized that the sunlight first hits the top of the mountains, and so he could measure the distance between the edge of the terminator and where the first mountains were lighting up, and use that to figure out how tall they must be in order to be hit by the sunlight. And he figured out to just within a few percent how tall mountains on the moon are hundreds of years before we actually went and measured them using astronauts and spacecraft and all of our fancy modern tools. You're probably not going to do a lot of lunar measuring, but the terminator is really where you want to focus when you're observing the moon. So when's the right time to look at the moon? It changes every month, because the moon's 28-day cycle isn't quite the same as our 30 or 31-day months. When we see a full moon or a new moon or a partial moon every month changes as the year progresses. And so you want to look at a lunar calendar. So I got this one from Wikipedia, and it shows all the phases of the moon for 2020. So I just find the month that I want to observe, say April, and then by moving from row to row, I can see when the moon will be in its different major phases. So for example, on April 1st, we have a quarter moon. On April 8th, we have the full moon. April 14th sees the 3/4 moon, and April 23rd sees the new moon. And so I know that I probably want to observe around April 1st or April 14th, where I got that nice terminator going down the middle, and stay away from looking at the moon on around April 8th or April 23rd, where it'll either be too bright or too dim for me to see as much detail. And that's basically it. The coolest, most amazing part of observing the moon is how easy it is. All you do is gotta look up, use your eyes, use your binoculars, and just see what you see. Every time I look, I see something new, I see something surprising, I see something wonderful. And so it's a great target to look at on Monday, and on Tuesday, and on Wednesday. As it moves from new moon to quarter moon to full moon, you'll see new details every day. So stay safe at home, but make sure you go out, take a peek up, and check out the amazing stuff that's waiting to be discovered.